The first thing that you need to write down if you're ready to start writing some stuff down is this. We use systems of equations when we solve for more than one variable. And the rule is this. You need as many equations as letters. Right? You got 4 letters, you need 4 equations. You got 5 letters, you need 5 equations. You got 6 letters, you need 6 equations. What we mostly do in Algebra 2 and Algebra 2 Trig and even pre-calculus, we really drill down on 2. We will actually even do 3, right? And it turns out there are 3 ways that we do this. One is guessing or plugging in, right? You can guess or you can plug in to see whether or not something works for both equations, right? It's a pain in the butt. No one does it. But if you're desperate, like I'll be honest, on a multiple choice test, this way totally works, right? If you've got 2 equations and you've got 4 choices, you just plug them in until you find the one that works. It actually, is a viable way of doing it. The second thing that we could do is we can always graph these babies. We're going to talk about that a tiny bit today. We don't do a ton of it in terms of the street. Summer breaks? Oh, okay. Oh, you got it. We don't do a ton of it because if you don't either have graph paper or a graphing a program or calculator, if you're not exact, it screws you up. But mostly what we do is we use our friend algebra, and we're going to do that for the next 2 days. That's substitution. That's that add and subtract method, right? We're going to drill down to make sure we're good at that. So we're going to talk about that. But before we do that, we're going to add some vocabulary that is tricky and that you may have heard last year. You didn't hear it from me last year. And it's nothing, Liam, that is, like tonight's stuff is not hard, but it's hard to, you have to memorize these stupid words. And they're weird enough that I literally had to go and make sure I have them because I get them confused because they're dumb. So here we go. You got Nana out there. You got Grandma, right? And this is how we do systems of equations, right? Systems of equations says this, that Nana, she loves you, right? So you and your twin brother or sister were born on the same day. That makes sense. And she comes and gives you $100 on that first day you're born. And every year she sends you a card with a $20 bill stuffed in it. Yay for you. But your sister, she only gives her 25 bucks because she didn't have anything else in her wallet on that day she's born. But to make up for it, every year on her birthday, she gives her $30. So here's what I want to know is there a time when you both will have the exact same amount of money? And there is. It turns out if you were going to put this on a graph, and you don't have to do this, you're just watching. Here's you get your $100 and Nana's giving you your money like this. Your sister started off with less. That is true. But eventually, because she's getting more money, she's going to pass you up. And right here, and you know where that happens? Because I looked it up online. I did the math. When you're 7.5 years old, for one day, 7.5, you will have the exact same amount of money. Yay. But then after that, guess what? Your sister starts kicking your ass, right? She's going to have more money. Will you ever catch up to her once she starts kicking your ass? No, you never will. Because if you cross one time, that's it. You cross that one time. That is all that will happen, right? So here that's happening. You're going off, and that is what we're looking for. So most of the time, 80% of the time, when we're doing systems of equations, we get one answer. And it's where they cross. We get one answer, right? One intersection. One answer for X, one answer for Y. Not two, not four, just one, because they can't circle back. So the first thing I want you to write for your notes is this. Oh, don't write bananas. Here's what happens. So I'd like you to draw a little graph, make two lines cross. Just make two lines cross. If you have two equations with, this is important, different slopes, you will eventually, maybe it'll be a while, get one answer. Okay, now here's where this gets weird. There's a math name for this. It's going to flip you out as we do this because they sound weird. When that happens, that is called a consistent pair. They are consistent. That means they're going to give you an answer, some type of answer. And because they have different slopes, they are also not the same line. I got one line this way, I got one line this way. They are also called independent. They are independent of each other. They're not dependent. They are not the same line. They're called consistent, independent. Here's what you need to know. Consistent equations give you an answer, and independent means that you just get one answer. Okay? This is going to get a little weird. Are we good? Consistent equations give you an answer, and independent ones means it's only going to be one answer. Because we're going to have some that are called consistent dependent, and you're going to get many answers, right? But we'll get there. The next thing that can happen is, what if this happens here? Let's see how many I am. Oh, I'm here right here. So we've got Jace's Nana. Oh, Jace does have a twin, huh? Okay. So what's your twin? Jocelyn, is that right? Oh, okay. So Jace has a twin. So Jace's Nana. So Jace's mom's got the two babies, and Jace's Nana comes over, and Jace's Nana, I don't want this to tape. She's not very nice. Jace's Nana's not very nice. So she sees Jace and she says, you know what? That's a cute kid. I'm going to give him $25 on his birthday, and here's $100 to start off. Yay. But then she sees his sister, and she's just beautiful, baby. She's just lovely and wonderful. Jace's crying, the baby, she's just sitting here. And so you know what her Nana says? I'm still going to give $25 a week, because that's a month, a year, because that's easy to remember. But you know what? That baby's beautiful. So guess what? She gets $1,000, right? That's just me. Do you know when Jace will catch up with her? Never. Never. Because you know what? They're parallel. They're never going to cross. Ever, ever, ever. They have the same slope, right? They have the same slope, but they have different starting places, right? Because it turns out that Jace's Nana was mean. Different starting places, a different B. And the word for that is inconsistent. Why? Because we don't get any type of answer. No answer at all. And that is called inconsistent. So you got consistent, independent, giving you one answer. You got inconsistent, giving you no answers. And then we've got the last, oh my God, and this is for you, Jace. In a little, how funny. Of course, I knew it was talking about you, but they heard me. And the last one is the weirdest one. This is the kind of Nana I'm going to be. because I'm a math now. So my son has twins. He doesn't have any babies. But he's 28. He could soon. So one baby I'm going to give this much money to, and the other baby I'm going to give this much money to because I'm a weird math person. And the other baby's like, well, that's stupid. Why are you doing that? Actually, my son would say that. He'd be like, really, Mom? Really? Why are you doing that? And I'm going to be laughing, ha, 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 because it turns out they are the same damn line. They don't look the same, but I'm like an idiot, and I'm like, oh, aren't I funny? And he's like, no, Mom, no one really likes you. So, because that's how my kids treat me. Because watch this. I'm going to times this by 5. I'm going to times this by 5. I'm going to times this by 5. And I get 25 minus, 25x minus y equals negative 100. I'm going to flip-flop the y and that 100, so I get 25x plus 100 equals y. They're the same stupid line. They're the same stupid line. So here's the craziest answer of all. When will they have the same amount of money? Every freaking day, right? Every birthday, even Steven. They get the same amount. I don't have one answer. I have a million answers, or I have until they die, right? That's a horrible thought. So when that happens, check this out. That is, come here, dude. Really? Come down. Why? Why? Why are you doing this to me? Oh my God, you're stuck. I'll just exit. That's okay. That's smart. So look what happens. If the lines lay on top of each other, this is what happens. They have the same slope. They have the same slope. And they have the same B because they're the same damn line. And I get many answers. The answer is actually infinite, right? Many answers. Now, we said consistent gives you an answer and inconsistent gives you an answer. This is consistent because it gives you an answer, but here's where it gets weird. It is not called independent because they're not independent lines. They're the same line, so it is called consistent dependent. And I know that's weird. I know that's weird, right? So what we're going to do, we're going to try a few. I'm going to give you some choice, some pairs, and you're going to try to tell me, here are your 3 choices. Consistent, independent, one answer. Consistent, dependent, many answers. Or inconsistent, no answers at all. Are we cool with that? Everyone got that down? Here we go. Okay, so I wrote some examples down. Let's try this first one. Nice and easy, nothing scary here. Okay, talk to your neighbors right now. Take a look at this. Here are your choices. Consistent, dependent, consistent, independent, or inconsistent. So talk to each other. Think to yourself, will they cross? And how many answers will I get? You're correct. Very nice. I heard Misha whispering over there to Trev. She says consistent, independent. And you know how she knew? Different slopes. Different slopes. The minute you have different slopes, they're going to cross. Not a lot of times, just once. Are you okay with that? You got to step up our game a little bit? How about this one? You guys ready? How about 4x minus 2y equals 2 and 10x minus 5y equals 5. Okay. Here's why. Consistent, independent. Because independent means that they are separate lines. Okay, now this one, here's what you got to do. I think that's hard to tell, so I'm going to get y by itself. That's going to be easier for me to look at it, to compare their slopes, to compare their b's. I need to see if they have different slopes. I need to see if they have different b's. I need to see what's going on there. So this is Tarantino if I was doing this, I get y by itself on both of them, and then take a look. And I would take a look. Remember, when the slopes are the same, we have two choices. Either they're never going to give you an answer, or they're going to give you a ton of answers. Look at that. They look tricky. They look different. But you know what? Slopes are the same and the B's are the same. That's the same damn line. They're the same stupid line. I get many answers, which means they are consistent but dependent. They lay on top of each other. Does that make sense? Last one to try for you guys, and then we got one other example, then I'm shutting up. I love this one. X, oh wait, I want to make sure I got it right. Oh, I like this. X plus y equals 8. 2x plus 2y equals 4. 8. No, we got 8. I'm going to make it interesting. Equals 8. There you go. The last one was consistent dependent, right? Because they do give you answers. They just give you a lot of X plus y. Yeah, that's not a 4. Sorry. Ooh, good, good, good. I heard that. Did you say same slope, different intercept? Which means same slope means that they are cruising along together. Different intercept means will they ever touch? No, inconsistent. Inconsistent. Nice, nice, nice. Okay, last thing I want to do is this. I want you on your table to write me a line. What if I said y equals 3x plus 5? Now, you're going to get a piece of use your whiteboard pen on this because I don't know what's wrong. Here's what I want you to do. I'd like you to write me a new line. You got lots of choices here. That would give me an answer. In other words, I want you to write me another line up there that would be consistent and independent. And you have a ton of choices. Like literally a billion choices. Could be the same B, doesn't even have to be the same B. It's consistent and independent. Different slopes. Love that. If you did 20 or 15x here plus 5, that is awesome. If you did the exact same line but put a negative there, that is awesome. All sorts of choices. If you put a 15 here, they just can't have the same slope. How about this? What if we took this and I want you to give me one that is inconsistent? I want you to take that bad boy, give me a line that is inconsistent. Inconsistent. Look at me walking around like some kind of inconsistent. Love that. Love that. Just change that 5. I love the fact that you can be so lazy that all you have to do is erase this guy and erase this guy, and you literally have 2 inconsistent lines. Same slope, different B. Now the last one I want you to do, I would like you to give me a consistent and independent line, but it cannot have a 3 or a 5 in it. It cannot have a 3 or a 5 in it. It's going to be consistent and dependent, same line, but it cannot have a 3 or a 5 in it. How could you mess with that guy to get rid of the 3 and the 5? What could you do that would make that could make that guy interesting? What could you maybe give to everybody? Love that. Love that. Don't forget your That's So guess what? I'm lazy. 100y equals, or 10y equals 30x plus 50, right? Doesn't have a 3 and a 5 in it. I just times everything through. Is that cool? That is it for today. You want to grab your phone so you can take a picture. Your homework answers are on your desk. Sorry if they're so weird looking. And here it is. The back ones, the ones that grab, maybe do 2 or 3 of them. I'm not asking you to fun. Let's see. Wow. Watch the video.